Next, the components of a homogeneous mixture are not visible with the naked eye or even under a microscope. A homogeneous mixture consists of only one phase. The single phase in which a homogeneous mixture occurs may be gaseous, liquid, or solid. For example, air is a homogeneous mixture of a number of gases like oxygen, nitrogen, carbon dioxide, ozone, etc., whereas petrol, kerosene oil, diesel oil, etc., are homogeneous mixtures of a number of liquid hydrocarbons. Similarly, alloys such as brass, bronze, etc., are homogeneous mixtures of metals, whereas salt or sugar dissolved in water gives a homogeneous mixture having only the liquid phase. All homogeneous mixtures are called solutions. Whereas gases can be mixed in any proportions, there is a limit in case of liquid and solid solution, depending upon their mutual solubility. A mixture is said to be heterogeneous if its composition is not uniform throughout. A heterogeneous mixture consists of two or more distinct phases. The components of a heterogeneous mixture are visible with the naked eye, or at least under a microscope. For example, the components of a mixture of iron, sulfur, and common salt can be seen with the naked eye, lying side by side, but the components of milk, which is also a heterogeneous mixture, though it looks to be homogeneous, the fats suspended in clear liquid can be seen under a microscope. A few other examples of the heterogeneous mixtures include smoke, a mixture of carbon particles plus air; gunpowder, a mixture of carbon, sulfur, and nitre; oil in water, copper sulfate, and sand, etc. Strictly speaking, air is also a heterogeneous mixture if dust particles are taken into considerations. The various characteristics the various characteristics mentioned in the definition of mixture can be explained taking the example of a mixture of iron filings, sulfur, and common salt. Firstly, they can be mixed in any proportion. Secondly, the mixture can be tested to see that it gives the test of iron, sulfur, and common salt. Thirdly, the mixture can be separated into its components by simple physical methods. Example: iron can be separated by simply moving the magnet into the mixture, whereas sulfur and common salt can be separated by making use of their solubility in different solvents. Example: sulfur can dissolve in carbon disulfide, whereas common salt is soluble in water. So any one of the two can be dissolved and then filtered. Difference between compound and mixture. The important points of difference between mixture and a compound are summarized. Okay, let us take note first. Mixture. The constraint of mixture may be present in any ratio. Mixture may or may not be homogeneous in nature. The properties of a mixture are midway between those of the constituent. The constituents of a mixture can be easily separated by simple mechanical means. Mixtures are formed as a result of physical change. When a mixture is formed, no heat, light, or electrical energy is absorbed or evolved. The melting and boiling points of mixtures are usually not sharp. Compound. The constituents of a compound are always present in a fixed ratio by mass. Compounds are always homogeneous in nature. The properties of a compound are entirely different from those of its constituents. The constituents of a compound cannot be easily separated by simple mechanical means. Energy in the form of heat or light is often required. Compounds are formed as a result of chemical change. Formation of a compound is always accompanied by absorption or evolution of heat, light, or electrical energy. Chemical compounds possess sharp melting and boiling points. Thank you.